So yeah, like I was saying, you've already done a little bit of this section already because we did 610 already, but we kind of switched the order just so you're not bogged down with all the notation that you're going to learn today while you're trying to do all the equation solving as well, because it's a little overwhelming. So I'm going to show you something, and you're going to notice today in your answers that they're pretty much the same as they were on your homework, right? So if you've already done your homework, you're going to see like, oh, it's just the same thing? Yes, it's the same thing. The only thing different today is just really how you write your work. So that's the one thing that's new, is how you're writing things down, and there's some new notation, there's some things that you haven't seen before, but in the end, the answers are going to look very similar to what you've already done. Okay, so rest assured, if you have this feeling as you're doing this, you're like, is that all I need to do? It's probably correct. Okay, sometimes you have that feeling it seems too easy and must be wrong, but in this case, it's okay. So just to review, we did something called the general solution, right? We did something called the general solution, which meant we had to write our answer with this format, right? It had to have this 2 pi n right there. And then we also threw in this, where n is an integer, and that's what that fancy z right there stands for. That z stands for integer. Integer. There we go. Integer. Okay. And what does this mean? It means this right here. N is any integer. And geometrically, what does that mean? So that meant that, let's say I had a cosine or sine of some angle here, that on the unit circle, you know, there's the answer. But if you're saying in general, well, we could have gone all the way around the circle. I kept on going, another 2 pi, and the cosine's identical, right? Or we could have gone backwards, and the cosine is identical. So we can go around the circle like 1, 2, 3, 5, 1,000, 20,000, right? And those are all going to have the same exact cosine or sine, right? Another way of looking at it is that, well, what time is it exactly 24 hours from right now? Right? Well, it's 1:46, right? 24 hours from now, it's a 1:46. It's the same idea that if we just go all the way around, we go a whole nother day, we have the same exact time. If I go back in time 24 hours exactly, it's 1:46. Kind of get the idea that the answer repeats itself every single time you go around the circle, just like the time of day repeats itself every new day. So it's kind of like asking, well, you know, when is it 1:46? Well, it's 1:46 right now, but also a day from now, 2 days from now, 3 days from now, 4 days from now, for an infinite number of times. And that's why we have this notation, is that it kind of encapsulates all the possible times it could be that 1:46 p.m., or in this case, you know, the sine of, you know, could equal this, or the cosine could equal this, right? It just accounts for all of it, just to be very, very thorough. Okay, so that's the reasoning for it. And the biggest lesson of all was that you had to remember to read the directions, because you had to know when to actually put this part and when you didn't need to. So anytime you saw the word general, that's when you had to do this blue part. Sometimes it was 2 pi, sometimes it was just pi. It just depends on the question. So you saw that in your assignment. Okay. So that's part of the review. Now we have this new looking thing here that says arc cosine, arc sine, and arc tangent. Okay. All this is just a way of writing, well, what does the y equal at this particular value? Okay. So for instance, I could say on your last homework, what's the sine of theta at, I don't know, root 3 over 2, right, in the first quadrant. That's the same thing as saying theta equals the arc sine of root 3 over 2. These are identical. And this is what you did on your homework last week. You just looked up on your unit circle, and you found the angles that match this. It's just another way of writing the same exact thing. It's just a little different, okay? Just a little different. And of course, we're using radians here, you know, everything that we're doing. And it's true for arc sine, arc cosine, arc tangent. It's just another way of writing it. We could say, technically, which we'll get into the future here a little bit, that if you're, you know, when you solve equations, like if you had something squared, if I had x squared, you know, equals 2x plus 1. Well, how do I get rid of an x squared? How do I take it to go from x squared to x? There's some function I need to do. Like in this case, the opposite of being squared, or the inverse of being squared, is square root, right? So you can think of this as like the inverse, that if I take the arc sine of both sides, right, arc sine of both sides, that the arc sine and the sine pretty much cancel each other out, and I'm left with just theta equals, like I would be here with x equals. And on the right-hand side, I now have arc sine of root 3 over 2. So it's an operator that lets us do the same thing on both sides, that lets us cancel out sine if we're actually really, you know, solving these thoroughly and showing all those little steps. Okay. It's not super important. It doesn't change your answer. It's just a more, I don't know, correct way of writing work when you're showing everything. Okay. Let's see here. So again, you know all the answers already. Just have to think, how does it relate to what you're already done? So if I did this, let me show you this. So if I wrote this like your last homework, it would look like this. Sine of theta equals 1/2. Right? That's the same thing of asking, what's the arc sine of 1/2? It's the same exact question. So we can go to here, go to our unit circle if we have it printed out, and say, well, where does it equal 1/2? Okay. Of course, sine being the y-coordinate, the rise, we'd say right here at pi over 6, and over here at 5 pi over 6. Those would be our two. So we could say pi over 6 and 5 pi over 6 would be our answers. Okay. As they appear, I'm marking it down. They appear right here and right here. Now, is this the complete answer? And this is the million-dollar question. Right? Is this the complete answer for this problem? How would I know? What's the word that gives it away? Say it. General. So am I finished? No. You see this word in the directions? Like I mentioned up here, if you see that word in the directions, we have this to put on there. We got to add that part on. So for each of these, right, I need to say, well, it's just not, the sine is not just 1/2 right here, but if I go around again and around again, the sine is continually going to be 1/2. If I go backwards all the way around, you know, negative 2 pi, another negative 2 pi, another one. If I go 2 pi and then any number of times around, as long as that number of times is a whole number, positive or negative, also known as integer, right, I'm going to get that answer. Same thing here. Right? So it's a big thing, especially when it comes to some tests. We can all be really good at solving problems and getting the answers, theta equals, but you have to be meticulous reading the directions as well and knowing when this part needs to be included on your answers or not. All right, just one more example. Let's look at, when is the arc tangent equal to root 3? So at what radian measures do you have a slope, basically a slope of that angle, if you will, that's equal to root 3? Now, if you took my advice last week, you kind of wrote that already on your unit circle. Like up here, I put right here, tangent equals root 3. So I know it's pi over 3, right, is where it equals root 3. So it's nice to have that, because that way, otherwise you have to go through and do rise over run or sine divided by cosine, and then as soon as you do root 3 over 2 divided by 2, root 3 over 2 divided by a half, then you would actually get the root 3. The 2's cancel out. You get root 3. So it's nice to have it on there and get familiar with it. So I know this one, pi over 3. Are there any others where it equals root 3? Alright, so you go back here, maybe go around. You would know that this line has a slope of root 3, so if I carry it down here, yes, 4 pi over 3 also has a slope of root 3, because it's the same exact straight line, right? So of course the same line would have to have the same slope, so 4 pi over 3 as well. The more you know that unit circle, the faster these things get. And of course, we're still in doing general values. Okay? But what's different about this? Right? So something's different about this. We could say, this one plus 2 pi n, and then this one plus 2 pi n, but these have a special relationship. So we saw this on the homework as well. Right? On this particular type of problem, the answers repeat every pi. So if I just go a half circle, right, halfway around, I get an answer. And I go another pi around, I get another answer. Another half circle, another pi, I get the answer. So we can actually say, instead of writing both of these and saying plus 2 pi n, I could just say, well, start at pi over 3 radians and just add pi. I'll get an answer, add pi, get another answer, add pi, get another answer, and then in reverse as well, it works that way. So we had these on your homework as well, where if we're not going to really use that one, we're just going to say instead of going 2 pi around, I only need to go pi around. Right. So a simpler way to write that. Yeah, question?
It doesn't matter which one you actually put, the pi over 3 or 4 pi over 3?
Technically, we should probably put the first quadrant one. That's the first one that shows up starting at 0. Yeah. Good question. All right, try number 1. See how that goes. Start by rationalizing the denominator, right? Because it has a radical on the bottom. All right, so as you probably notice, arc cosine of negative root 2 over 2. And look that up. Cosine negative root 2 over 2, that would be the second and third quadrants. Right? And we're looking at 3 pi over 4 and 5 pi over 4. Right? They'll both have an x-coordinate of negative root 2 over 2. 3 pi over 4 and 5 pi over 4. And these don't have a shortcut answer like on the second one here, so we're just going to have the 2 plus 2 pi n. Or n's an integer. All right. Any clarifications needed on there? Yep, question?
Back to the real quick. If we were to write both of them out and put 2 pi for each of them, would that be wrong?
Yeah. It would just be like putting 4/8 instead of 1/2. It's just kind of like reducing a fraction, like make it simple as possible whenever you can. Yeah. All right, so new notation, same type of answer, general form, right? We haven't changed what our answer looks like. We have to look for that word general when we see it. Make sure you write that blue part in. Okay, so a little good practice warm up. Now the next part. Here's what's going to happen. We're going to start using calculators and things like that, And the problem is that we want to put these values in calculators. And you can see with this format, there's an infinite number of answers. So which ones should I use? Should I use, like, if I started doing the calculator work and getting answers, should I use pi over 3 or 4 pi over 3? If it asks for what has a slope of root 3. So you can see it's a little problematic as we transition, later on to using calculators and doing this math, is that when we do math collectively, we're talking about, well, what angle has a slope of root 3? We all need to have the same answer in mind and use that same answer. So what happens is, for certain functions, which when we get to graphing will be more clear, is that we start saying, like, well, if we're going to do arc cosine, let's use the answer that's between 0 and pi. So anytime you do anything with cosine, moving forward, from 0 to pi right here, we're going to use just what shows up in the first and second quadrant only. Okay? And why is that? Well, if I'm saying what's the cosine, what has a cosine of root 3 over 2? Well, pi over 6 does, but so does 11 pi over 6. But moving forward, that's why we're going to say, well, we're only going to use the first and second quadrant. So our answer will be pi over 6, right? It makes sure, you might remember this, it makes sure that we're actually working with a function, which means for every single answer, there's only input, there's only one output. So if I ask what has a cosine of root 3 over 2, every single time I'm going to get pi over 6, and not have half of you guys getting pi over 6, and the other half are saying, wait a minute, this one down here is also root 3 over 2. I want to use 11 pi over 6 instead. Right? It makes us all consistent, right, with no repeated or different answers as we go forward. Right? So it's just being very careful. Right? So you can see, for that reason, right, when we're doing arc cosine, we're going to stick to whatever answer is in the first or second quadrant. And the same thing happens with arc sine. Right? You can see it's negative pi over 2 to pi over 2, right? Which basically says stick to the first and fourth quadrants. This is 3 pi over 2, but it's also the same as negative pi over 2. So it goes from negative 1 all the way to positive 1. And then none of the signs repeat. If you go over here, you can see it's negative root 3 over 2, negative, negative, and then it goes positive, positive, positive. So each of those signs only appears one time, so there's no possibility of me accidentally choosing two different angles that happen to have the same sign. So for sine, we stick to the fourth and first quadrant. Right. That's what these mean right now. These are two different ways of saying the same thing. From 0 to pi means first and second quadrant. From negative pi over 2 to pi over 2 means it has to be in the first or fourth quadrant, and you can see that these are the same. So this is also going to be first or fourth quadrant. For the same reason, right? Because these tangents don't repeat. It's negative root 3, negative 1, negative root 3 over 3, 0, positive root 3 over 3, positive 1, positive root 3. So there's no repeating tangents here at all. So that's why we use first and fourth quadrant. Okay. And then when we start graphing all these next week, we'll see even further why that makes more sense. Okay, so very good reason for doing it this way. So you'll notice that here it says something slightly different. The directions have changed. It goes from general to principal. When you see principal, that means you abide by these restrictions. You'll also notice that we went from lowercase to uppercase. That's not random. Okay, that's a definite meaning right there. So it's one of those small, tiny details on your test. Like, how come I got this? I put these two answer, and I'll be like, there's an uppercase A. And you have to know what that means. Kind of like you have to know what it means when it says general in the directions. It's the smallest little detail, but this and this alone is telling you right, that you have to look at, well, tangent, I want my answer. Well, first of all, it's telling you two things. It's telling you there's one answer. Right? It tells you that there's one answer. So that if you look up on your unit circle, oh, it's -1. Which ones have a slope of -1? All right, over here. Okay, 3 pi over 4. That has a slope of -1. And, oh, 7 pi over 4. That has a slope of -1 also right here. So, I got two answers, 3 pi over 4 and 7 pi over 4. And this is what you did on your homework. Right? But when you see this capital A, say see principal, you have to remember, for tangent, it's only the answers in the first and fourth quadrant. So we throw out that one, because that's in the second quadrant. So we don't want that. So we have one single answer. Remember, we want one answer. So you'll have both of those, and you need to know which one it is that you keep and which one you toss. Okay? All right, do the same thing for arc cosine, -1. You guys try that one. So where did cosine equal -1? At what angle? At pi. Yeah. Are there any others? No. So it's kind of a nice problem that, well, here we had to kind of go through and figure out which one's the right one. Our goal is one answer, and this only happens at a one angle, so it just equals pi. And that still falls within our domain, right? Where we have arc cosine has to be between 0 and pi. It also includes pi. Has that equal to. So it's okay to have pi as an answer. So that's it. So just illustrating the idea that sometimes you'll have two possibilities. You got to know which one to eliminate. Other times when you're dealing with the 90-degree increments, the cosines and sines of zeros and ones and -1s, you might have just one answer and it's a straightforward question. Okay. In that sense, it's a little bit nicer. Okay. So again, trust yourself. You already know these answers. It's just kind of like, you know, notation and maybe what answer to toss. All right. So last two, just as an example. Let's take a look at this. We have a very similar problem that you've done before. Let me rewrite this in a different way that you're familiar with. Okay. Given cosine of theta equals 4/5, find cotangent. Right? Whereas on your test, it actually said, well, here's one of them. Find all the other 5, right? You found the cosecant, the secant, the tangent, the sine. If you just have one of them, you can find the other 5 by drawing the triangle. So these are the same question. It's just written in a slightly different way. So you've already taken a quiz on this. You've already done homework on how to get the right answers. So it's just, you'll notice, written differently. So just to reiterate, though, 4/5. All right, so that's the run cosine. I want to go all the way here. Cosine is adjacent over hypotenuse, right? So that means our run is 4. Our hypotenuse is 5. And then you can always do Pythagorean theorem, find out what the missing value is. In this case, by now, hopefully we're good at identifying, well, we see 4 or 5, we know the missing side is 3. Pythagorean theorem. If not, you can do a squared plus b squared equals c squared. 25 minus 16 is 9. Square root of 9 is 3. Okay. So we know, right now, for our purposes, our full triangle, and we need to find the cotangent. Now you have to remember, what is cotangent? The reciprocal of tangent. If tangent is rise over run, up 3/4, cotangent is reciprocal. It's like rise over, or run over rise, right? Or some others like to think about, instead of that, cosine over sine. That means the same exact thing, right? So it's a little bit easier, and we can say, well, the run is 4, right? That's the run. The rise is 3, so I can say that this equals 4 over 3. Now, if you really did want to do, the cosine and sine, you could do a cosine is, 4 over 5. The sine is 3 over 5. Of course, when you do the arithmetic, those 5s just cancel out, and you're left with 4 over 3 as well. So there's different ways of doing it. Whatever one you're comfortable with, you can go with. Right? If you like just the more straightforward, that's fine. Now, is this the only answer? All right, this is the skill for today. This is the main thing. So do I have one answer, or do I have multiple answers? And how would I know? Because it says value or values. So how do I know? How many say 2 answers? How many say 1 answer? Yeah, lowercase a. So how many answers? 2. Yeah. So we have to keep on going. So where is the other cosine that equals 4 over 5? So where else is cosine positive? Right? So you go here and say, okay, all star, sine's positive, tangent's positive. Oh, 4th quadrant. Cosine's positive in both of these quadrants, right? Because here all of them are positive. Here only cosine's positive. So I got another answer in the 4th quadrant. All right? So these are the little things we have to know. And how do you actually draw that? Well, it's just down here. We also have this one. All right? That triangle down here also has 4 over 5 as cosine. Now the rise is now -3 instead of +3. Right? Which means my cotangent, right? It's still the cosine, or the run is still 4, but my rise is now -3. Remember, as run over rise or cosine over sine, sine's negative in the 4th quadrant. So I get 2 answers. I get 4 over 3, but I also get 4 over -3. And we usually don't leave a negative in the denominator. We can put it in the front. Or we can put it on top. Same thing. I'll leave it in front. So we get 2 answers. The only way I knew that, because it says value, so it said, well, we could have some problems that have more than one answer, is the fact that this was a lowercase a. I mean, that's the littlest thing that it comes down to that you have to look for, okay? So keep that in mind. It's all in the details. That being said, how many answers are on number 3? 1. Yeah, we know right here. We're going to deal with just the principal, right? And that's the only. What quadrant am I going to work with if I'm dealing with arc sine? Arc sine, 1 and 4, right? And it also says do the tangent, which is also 1 and 4. So and where is sine actually negative? It's in the 4th quadrant. So we have to dissect this and kind of realize this could only be 1st and 4th quadrant to begin with, right? Because it's a capital A. But the sine is negative, and we know everything's positive in the 1st quadrant, so that's out. So we're dealing with the triangle that's in the 4th quadrant. So you see how much thought and thinking goes into that one letter capitalized? Very important small detail, right? But it basically determines the whole problem. So we got a 5. it's signed, so this is the rise. You know, it's down 3. That supports the idea that we're in the 4th quadrant because I had to go down. It's negative down here. All right. So what is the run? Yeah, it's just 4. Notice how it's actually the same triangle we were just working with here. So here's the triangle. It has an arc sine of negative 3. Negative 3 over 5. And it's asking basically, what's the tangent? What's the slope? What's the rise over run of this? And what would the answer be? Yep, negative 3 would be the rise. 4 would be the run. So negative 3 over 4. That's what that will equal. All things and skills we've done before. Right? The only thing here is looking at both of these and saying, why did this one have 2 answers? Why does this one have 1 answer? Right? And differentiating between the 2 types of questions that are basically identical, except one has a capital A and one has a lowercase a. Okay. So small things to look for, right? But otherwise, we can handle this. All right. Any clarifications from here? Yes.
Capital A being the principal, lowercase a is general.
Yep. Capital A is principal. Okay. And lowercase is going to be general. Well, lowercase could just be get both answers, right? So lowercase could be both answers, and if it says general, then we have to add that on. Okay. So it depends if the word general is there. So if you just have this, right, and it doesn't say general, then you just put these 2 answers and say I'm done. It includes the whole unit circle.
So capital A is the entire principal, lowercase a is 2 answers, if it says general, then you add that on.
Exactly. Very good. Okay. There's your assignment.